In this video, we're going to be applying some main idea and details to math problems. So we're going to use that skill of main idea and especially the skill of locating details to understand and solve some word problems. You will need a calculator for this exercise, and I will be showing you or telling you some calculator keystrokes to use. Before we get started, I want to show you a mind map for word problems. This is something that I made up years and years ago to help my math students understand how to solve word problems. And I used the word roses to help them remember the steps. So the R in the word roses stands for read. We want to read, underline the question, write the question, identify the units for your answer. O stands for organize, and this is the important step. This is where you will get the answer right or get the answer wrong. If you do the organization step correctly, you will get the answer right. This is where the difficulty is with word problems. And some tips on this one: you need to write every number in the problem with its unit, put like units together, write keywords, get rid of junk. If someone or something is moving, draw a picture and ask yourself if there is a formula that applies. Set up and solve, that is this S, and this is what most people start with. They completely skip those first two steps and they go directly here. And that's why they miss a lot of these. The true difficult step, in my opinion, is right here. It's the organizing. E stands for examine. Check your calculations, work the problem a different way, compare your answer to classmates' answers if it's appropriate. Obviously, on a test, that's not appropriate, but if you're working together with your classmates, compare answers and see if you agree. And then finally, see if it fits. Does your answer make sense? You want to check the unit that you identified up here to be sure that they match. Is your answer too big or too small to make sense? So if you think through these steps, you will become a much better problem solver. And I'm going to show you some examples of how to do this process. So the main idea here is the problem solving process. The details are these individual pieces of this process, and we're going to be practicing those right now. So if you look with me at number 1, let's read the problem. That is the R step. So read, we need to read it, underline the question. We also want to identify the units. Amy bought 3 packs of pencils for $1.50 each and 2 notebooks for $2.75 each. If she gave the cashier a $20 bill, how much change did she receive? So here's the question. I think I'm going to highlight it instead of underline it. How much change did she receive? So the units that we're looking for will be dollars and cents. We're looking for money. The organize step, we need to pull out all of the numbers. So we have 3 packs of pencils. And those are $1.50 per pack. Those two things go together. They're in the same sentence. And then we have 2 notebooks. And those are $2.75 each. Those two things go together and I need a $sign on that 150. And then I have the $20 bill. And we're going to need all of these numbers to solve this problem. And again, the question is how much change. That word change in a math problem means to subtract. Okay, set up and solve. So first I'm going to set this up in words. I'm going to take the money that Amy had, and we're going to minus the pencils and the notebooks. And I want to combine the pencils and the notebooks before I do the minusing. So we have $20 that she had. Minus is subtraction. That's that word change. Okay, the pencils, she had 3 packages. And those are $1.50 for each pack. So we need to multiply those two. And the notebooks, she had 2 of those. And I'm just going to do it this way, times $2.75 each. And those would be the purchases. So I've set it up. I just need to solve it. So the first thing I'm going to do is change colors so you can see it. I'm going to do 3 times $1.50. And you can use your calculator to do this. I encourage you to, because you don't want to make simple errors in math and miss the whole problem. So 3 times 1.50 is 4.5. And you can make that 450 if you want to. And then we're going to do 2 times 2.75, and that's 5.5 or $5.50. And the word and here means to add. So we're going to add up our purchases. We're getting there. So we have 20 minus 450 plus 550 equals 10. So this much is $10. And 20 minus 10 is 10. So we finally have an answer. E simply means to check my work, examine what I've done. So let's work it again. We have $1.50 times 3, that's $4.50. 2 times 2.75 is $5.50. Add those together, you get $10, and then subtract that from 20, you get $10. So to see if it fits, her change is $10. And that problem is solved. And you see how the roses are in there. Roses is just an acronym to help you remember the steps. ROSES. Number 2. Read the problem, underline or highlight the question. A recipe calls for 2 cups of flour to make 12 cookies. If James wants to make 36 cookies, how many cups of flour does he need? How many cups of flour? So our answer will be in terms of cups of flour. Okay, so let's organize. I know that it takes 2 cups of flour to make 12 cookies. Those go together. And he wants to make 36 cookies. So 2 cups of flour per dozen, and he wants to make 3 dozen. So we need all of those numbers to solve this problem. Now, I'm going to go a step further, and I'm going to draw just a visual to help you see this. Let's put 12 cookies in here. And you know I didn't draw it big enough. Maybe I did. Okay, so there is 1 dozen cookies. So let's visualize here. I'm going to take that picture. So this is 12 cookies. And we know that that goes with 2 cups of flour. So let's add another box of cookies. And of course, it's going to not let me do that. Sorry, I thought I had a great idea here, but I'm not sure I did. Let's try this. Okay. Paste. There we go. So here comes another dozen. That's another 12. 12 and 12, that's 24. If I put 1 more in there, there's my 36. Because 12 plus 12 plus 12 is 36. So this actually helps you see how many cups of flour you need. And there are a couple of ways you could set it up. You could even use a proportion here if you know how to do that. But I think I'm going to do it this way. Let's do it this way. The first dozen, that's 12. Plus the second dozen. That's the second 12. The second box of cookies. Plus the third dozen. That's the third box of cookies. But remember, we're interested in the cups of flour. So the first dozen needs 2 cups. The second dozen needs 2 cups. And the third dozen needs 2 cups. And if you add those up, you are going to get 6 cups. And if you want to check it, another way to check it would be to add it up right here. 2, 4, 6. I like that. It checks out. So let's see if it fits. 6 cups of flour for 3 dozen cookies. That makes sense to me. That's not too big or too small, and it does match those units back here in step 1. So we have cups of flour, organize, set up and solve, examine it, and then see if it fits. So Rose's works every time. Number 3. There are 24 students in a classroom. How many students, if 1/3 of them are absent, how many students are present? So the question is, how many students are present. Okay, so we're looking for students. And to organize, we know that our classroom holds 24 students. We know that a third of them are absent. That word of is a key word when you have it with a fraction like that. That is a multiplying situation. Oops, I want to save that color. 1/3 of, that means 1/3 times something. And we definitely need all of these numbers to solve this problem. I think, though, that I'm going to draw a picture for you. So let's just make a classroom here. Oops, sorry. The caffeine's wearing off, but I still can't draw. Okay, so this is the classroom, and we're going to cut it into 3 sections, equal sections. So let's start putting students in our class. And I think rather than try to, let me see. No. Gosh, sorry. It's late at night and I'm sleepy. Okay, so here's a student. I'm going to drop that student right in here. Okay. Now, if you know the answer, don't go through all this. And I'm going to show you a mathematical way to do it. But let's visualize it first. Pictures are important. Okay, so here comes the second student. This is not going to work, guys, because it'll take me forever. So let me just go back here and do it this way. Okay, here's the first student, second student, third student, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12. So we're halfway there. We've got to get to 24. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we've divided our students up, and it says 1/3, so that's this section of the class is absent. Maybe there's flu or something going. That's a lot of people. So here's 1/3. So how many students are present? All right. So to set it up and solve, I will show you the mathematical way to do it. But we can look at this and tell if 1/3 are absent, that means all of these folks in this other section of the class are present. So these folks are in class that day. We just need to count them. Or you could say 24 minus the blue section. You could do it lots of different ways. But this yellow section is the group that is present. All right, if you want to set this up mathematically, this is how you do it. 1/3 of the class is absent. So 1/3 of 24, that's our class, is absent. So on your calculator, you will do 1/3 times 24. And let me walk you through how to do that, just in case you may not know how to do it on the calculator. And I'm going to draw some buttons here just to keep me going. You want to always, always, always start with all clear. So all clear. 1, ABC. Okay, something's weird with my iPad. It's wanting to do those words instead of, sorry, it's working. It's just not working the way I want it to. So there's the fraction, 1/3. The word of means multiply in this situation. And then you need to put in your whole class. Your whole class is 24. And don't forget to press equal. That is your last step. So 1/3 of 24 is, you should get 8. So 8 are absent. That wasn't the question. The question is how many are present. So we have to say 24 minus 8 is 16 present. And you can check this one using your visual. Count the dots in the yellow section, and that gives you 16 people. So the answer, 16 students are absent? No. 16 students are present. You have to pay close attention to details. And if you look back, you see your roses are right there. It will work every single time. But it's this O step that is the critical piece. All right, number 4. Emma is planning a trip to the zoo. The admission fee is $8 per child and $12 per adult. Okay, the main idea, we're going to the zoo. It's the details that matter here. If she is bringing 2 children and 3 adults, how much will it cost for the entire family to enter? So the question, how much will it cost for the entire family? So we're looking for money this time. We're looking for dollars for the whole family. So whatever we get, we need to have dollars. We're looking for money. So let's organize. We have $8. I like that because I'm looking for dollars. That's for child. And then we have $12 for adults. And then we have 2 children that are going. And 3 adults are going. So you see how I'm grouping those like units together, the children and the adults, because they're separate prices. So to set it up, I need to know the cost for the children and the adults. Entire family, we want to include everyone. So the children are $8 and we have 2 kids. The adults are $12 and we have 3 of those. The word and is addition. 8 times 2 is 16. 12 times 3 is 36. And we need to add those together to solve. And I'm thinking 52. But I'm going to check that on my calculator. I have dyslexia and I don't do well with adding and subtracting in my head. It's hard for me to line things up. But when I checked it, I got 52. It did check out to be true. So the answer is $52 for a family of 5. That's about right. That makes sense. If it were 520, that would not fit. Or $5.20 would not fit. But $52 for the whole family, that is a reasonable answer. So again, there are the roses, and it will lead you to your answer. Number 5. A rectangular garden has a length of 12 meters and a width of 8 meters. If each square meter of the garden costs $2 to maintain, how much will it cost to maintain the entire garden for a year? Now, I don't know really where that year thing is coming from. I tell you what, let's scratch that out. I used an artificial intelligence piece to write these, and I should have already caught that. But let's just cross that out, because that's extra information. I think I would have eliminated that if I had seen it before now. Okay, the question is, how much will it cost to maintain the entire garden? So the question is, how much will it cost? We are looking for dollars to maintain. So let's organize, and you know what I'm going to do on this one. If they're talking about a rectangle, I want to draw myself a rectangle. And oh boy, can I not draw, but it snaps too. So this is 12 meters long, that's length, and 8 meters wide. And we know that each square in that garden costs $2 to maintain. So essentially what I want to do is find out how many squares are in there. So we want to know how many of those squares will be there. So this one is going to need a formula. We need to know the area of a rectangle. And that formula is length times width. Right? So let's go ahead and multiply. Length times width. Use your calculator. And you get 12 times 8. That's going to be 96. And that's square meters. So in this garden, there are 96 of those squares. We're ready to set it up and solve. We're going to take $2 times each square. So that's $2 times 96 squares. And 2 times 96 is 192. And I just checked that on my calculator. So see if it fits. $192 to maintain the garden. And I assume that's for a year, the way it was worded. But again, I want to just ignore that for the year part. So we have ROSES, and we have an answer. Number 6. Sarah has $45. She spent 1/4 of her money on a dress and 3/5 of the remaining money on shoes. How much money does she have left? How much money is the question. Left is a keyword that means subtraction. So at some point, we're going to have to subtract to find the amount of money left over. Okay. So they tell me that she's starting with $45. So let's just draw a visual. Again, I like visuals. I will show you the mathematical way, but let's see if we can visualize it first. So I'm going to draw this box and let that represent her money. And it mentions 1/4, so let's cut this into 1, 2, and pretend those are all the same size. So if this whole box is $45, I'm going to do 45 divided by 4 to get 1125, 1125, 1125, and 1125. And 1/4 of her money went for a dress. So 1/4 of her money, let's go ahead and color just to keep it organized. 1/4 of that money is for a dress. So let's figure out how much she had left. Let's do 1125 times 3. Okay, so 1125, that's what's left right here. 1125 3 times. Sorry, I took a little too much. 1125 times 3 is going to be $33.75. Okay, so that was what was left over. But she didn't spend all of that on shoes. She only spent 3/5 of that. So not that whole thing. Let's do it this way. Let's bring this out here and let me cut this into fifths. So we have 1, 2, 3. Oops, that is nowhere near accurate. Let's try again. 1, 2, 3, 4, 5. And 3/5 of that, not the whole 33.75, but 3/5 of that. So we have these 3, or you could pick any 3, but I'm going to use these 3. That would be the shoe portion, 3 out of those 5 parts. So let's do 33.75 divided by 5. That's 675 675, 675, 675, and 675. So this much, 675 times 3. This is a tough problem. Is 2025. That was for shoes. So we want to know how much is left. How much is this right here? So it's 675 times 2. And that is 1350 left over. Okay. So let's set it up mathematically so you can see how it looks that way. So we have $45 minus the dress minus the shoes. So the dress was 1/4 of 45. Okay. And the shoes would be 3/5 of whatever was left over. And we know that that was $33.75. So we have 1/4 of 45. That's going to be 1/4 times 45. And you use your fraction key like we did up above. So that's 1125. And then 3/5 of 33.75 on the calculator is going to be $20.25. So 45 minus 1125 minus 20.25 is 13.5, which is 1350. So by working it two different ways, I have checked my work. I got the same thing for both. And my answer is going to be $13.50 left over. Tough problem. That one is not an easy one. None of these are easy. Okay, number 7. A car travels at an average speed of 60 miles per hour. If the car travels for 3 hours, how far did it travel? So the question is, how far did it travel? And this particular car is measured in miles, not kilometers per hour. So my answer will be in terms of miles. How far? That's how many miles. Now, I have a rule of thumb. If my problem is about something moving, I draw it. And I've been doing that now for a lot of years. So I'm going to draw a road here. And I'm going to mark the starting point and the stopping point. So this is start and this is end. And we know that for every hour, the car travels 60 miles. So I'm going to divide this up and say 60 miles, 1 hour, 60 miles an hour. So in another hour, we would have another 60 miles. That's a total of 2 hours. And then another 60 miles, another hour. And this would go on as long as the car goes. But it tells us that it goes for 3 hours. So we have 1 hour, 2 hours, 3 hours. There are the 3 hours. So in those 3 hours, how many miles do we have? And you can just add them up. 60 plus 60 plus 60. And that's going to be 180. You could also say 60 times 3 to get 180. But either way you do it, the car would travel 180 miles. And roses worked for me again. The main idea, how many miles traveled. The details are the way to find out. Number 8. Jason is reading a book that has 240 pages. If he reads 30 pages each day, how many days will it take him to finish the book? So our question is how many days to finish? To read the whole book. Let's say it that way. So let me organize for you. And let me think. I think I'm going to do it this way. I'm going to draw myself a picture to represent one day. So one day goes with how many pages? 30. You could do this with a proportion. I'm going to show you another way to do it as well. But let's visualize it first. So one day is 30 pages. 2 days would be how many pages? 60. 3 days. 90. 4 days. 120. 5 days. 150. 6 days. 180. We're getting closer. 7 days. 210. 8 days. And there it is. 240. It would take 8 days to make it to 240. Here is another way to do it. What have I done with that book? This is the whole book right here. The whole book got divided up into days. So 240 pages divided by 30 pages per day. $240 divided by 30 is 8. And either way you do this problem, you get 8. So it would take 8 days to finish. And again, ROSES. It works every time. Number 9. There are 36 students in a class. If 1/6 of them bring their lunch and 1/3 of the remaining students buy lunch from the cafeteria, how many students bring their lunch and how many buy from the cafeteria? So this is a compound question. We have how many students bring their lunch and how many buy. So we have to provide 2 answers this time. We want to know the students who bring their lunch and since this is a compound question, I'm going to make a line and say students who buy their lunch. I'm looking for 2 answers. Okay, so let's organize this problem, and you know what I'm going to do. I'm going to draw the class. The first fraction I get is the 1/6, so I'm going to go ahead and divide up my class. I misjudged again. There's 1, 2, 3, 4. Pretend that is even and level. It's awful, but it'll work. And let's start putting our students in the class. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm halfway there. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So there are my 36 kids, or adults. It could be a college class. And 1/6 of them bring their lunch. So let's take one of those 6s and let that be the ones who bring their lunch. So I can already tell you that 6 of them bring their lunch. And 1/3 of the remaining students. So I'm going to redefine my lines a little bit. I'm going to take these out to see the remaining students. And I'm not sure, this is not going to be everybody, so I'm not sure what. Let me just hush. So how many are remaining? If you take the 36 minus the 6 who bring their lunch, that's 30 remaining in this section right here. Let me color it for you just because we're visualizing. So here is the remaining group. That's that 30. But that's not the question. It says that 1/6 of them bring their lunch, so we take them out, and then 1/3 of the remaining students. So we are going to set up and solve 1/3 of the remaining group. And these are the ones who buy at the cafeteria. So 1/3 of 30. You can do that in your head, or you can do it with a calculator. That's 1/3 times 30. and that's going to be 10. Another way to visualize it is to take this group and cut it into thirds. So 10 is in each of those sections. So we can prove that our math is correct using that model. So see if it fits. We have 6 students who bring their lunches, 10 students who buy their lunches, and I'm not sure about the others. Maybe they don't eat lunch, this group. But there are a bunch of students who are not in the bring or buy category. But that doesn't matter. They ask us to find the brings and the buys, and we did that. So as long as you've answered their question and it fits, you're good to go. Number 10. A box contains 48 chocolates. If 3/4 of the chocolates are dark chocolate and the rest are milk chocolate, how many milk chocolates are there? So the question is, how many milk chocolate? Okay, so let's do a visual. You don't have to do it this way, but for those who like visuals, this is a good way to do it. We're going to divide this up into fourths. So 1, 2, 3, 4. And let's put in 48 chocolates. I won't bore you with counting out loud. I'm just dropping in chocolates. 15, 16, 20, 24, 28, 32, 36, 40, 44, 48. So we put our 48 chocolates in there. And it says that 3 of those 4 sections, so let me just color it rather than try to highlight it. Or I'm sorry, erase it. There's 1/3, 2/3, 3/3 of 3 out of 4, 3/4. And those are the dark chocolates. And so the ones left over will be the milk chocolates, which would be my favorite. I do not like dark chocolate. So these are the milk chocolates. You can just count the dots in there if you want to. You can also do this mathematically. 3/4 of 48 are dark chocolates. So 3/4 times 48 are dark. And your calculator will do this for you. So this will be 36 are dark, but that's not the question. The question is how many are milk. So you would have to say 48 minus 36 equals 12 to get the milk chocolates. And that is confirmed by the diagram over here. So let's say yes, that is true. That 12 are milk chocolates. Number 11. And I didn't highlight the question on this one, did I? How many milk chocolates are there? Did I do it on? Yes. Okay, number 11. Mrs. Smith baked 60 cookies for a school fundraiser. She packed them equally into 6 boxes. How many cookies are in each box? So the question, how many cookies per box? So to organize this one, I'm going to pretend that I am Mrs. Smith. And I'm baking cookies. They're in the oven. And so I get the boxes out of the cupboard and I put them out on the table. Because as soon as the cookies are done, I'm going to load the cookies into the boxes. And how many boxes do I need? We need 6 of them. So I'm going to open up the boxes. You could even put a ribbon on them while the cookies are baking. I set up my 6 boxes. And then when those cookies come out of the oven, I start putting them in the boxes. 1, 2, 3, 4, 5, 6. I got to get to 60. So how many times am I going to have to do this? There's a box. And rather than sit here and draw all of those, I do want you to see the visual. There is some good stuff happening when you think through this. So here's a box. And Mrs. Smith is going to have identical boxes. You don't want some boxes to have more than others. You want everybody to get the same amount. This is even math. What kind of math am I doing? What did I do with the cookies and these boxes? There's 10, 20, 30, 40 cookies. Here's 50 cookies. And here is 60 cookies. That is division. So to set it up mathematically, you take the 60 cookies and you divide those up into 6 boxes. And that leaves you with 10 cookies per box. So not an even dozen. Only 10 cookies per box. And Rose's worked yet again. I don't think I highlighted up here. I'm getting sleepy, but we'll finish these. Number 12. A bike store sold 24 bikes in a month. If 2/3 of them were mountain bikes and the rest were road bikes, how many road bikes did they sell? How many road bikes? I also want you to note the word rest. That means subtraction. But the question is how many road bikes. So if you want a visual model, we want to draw a model for the bikes, and the fraction is in terms of thirds. So let's cut our model into 3 equal parts, and then let's divvy up those 24 bikes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And let's mark off the mountain bikes. That's 2 out of the 3 sections, 2/3. So these are your mountain bikes. And that means the rest, that other section, are your road bikes. So this section will be the road bikes. So you can count them there. If you want to set it up mathematically, you would say that 2/3 of 24 are mountain. So 2/3 times 24, that's going to be 16, are mountain. But that's not the question. That's why that first step, the R, is so important. Because you have to say 24 minus 16 to get 8 road bikes. And whether you use the model or the math, you get 8. And that's our answer. 8 are road bikes. We're going to be really good with this kind of problem by the time we get finished here. Roses works every time. Number 13. The perimeter of a rectangle is 36 centimeters. If the length is 3 times the width, what are the dimensions of the rectangle? So this is an algebra question. What are the dimensions? And that means we need to know the length and the width. We need to know both of those dimensions. And to organize it, of course, I'm going to draw it because it's talking about a rectangle. And they tell me that the length is 3 times the width. And this would be the width. The length is 3 times the width. And there's a formula that works for this one. Perimeter is 2 times the length plus 2 times the width. And the length is 3W. The width is just plain old W. So we have 2 times 3, that's 6 W's, plus 2 W's. So the perimeter is 8 W's, 8 of those units to make that whole distance around. So let's set this one up and solve. If the perimeter is 36, that means that makes up those 8 units. So 8 into 36, that's not going to be an even number. So let's do 36 divided by 8 to get 4.5. But then we need to go back and substitute that in. This is an algebra problem. So this width will be 4.5. And then 3 times 4.5 is 13.5. And these are in terms of centimeters. So there are your dimensions. The length, the long side, is 13.5 centimeters. The width is 4.5 centimeters. And if you want to check that, let's add them up on the calculator. We've got 2 of the 13.5s and 2 of the 4.5s. And that gives us 36. So we can check yet again that our math is correct. This is not an easy problem. This is an algebra problem and geometry all rolled into one. Number 14. A farmer has 64 chickens. He wants to divide them equally into 8 pens. How many chickens will be in each pen? This one is full of keywords. We have divide, we have equally, and we have each. So this one is screaming at me to divide. The question that we need to answer is how many chickens per pen? And I'm going to draw just the basic model, but I won't put all 64 chickens in there. That's a lot of chickens. So here's what they're saying. Let's suppose that this is the farmer's farm. Okay? And he wants to divide his farm, the space he has for chickens, into 8 pens. So he's going to start putting chickens in there all the way to 64. You get the idea. We won't take the time to do that. The setup and solve will be the chickens divided by the pens. So 64 chickens divided by 8 pens is 8. And that will be 8 chickens per pen. I think I am going to finish it because that will be my checking. So 2, 3, let's do it this way. There's 16. Here comes 24. Let's do 3 more at a time. This will give us 48. We're getting there. Let's go ahead and put 2 more to get 8 chickens per pen, and that will give us our 64 chickens in total, divided nicely up into 8 pens. This is a pen, and there are 8 chickens in there. And Rosa's worked yet again. Number 15. There are 30 students in a music class. If 2/5 of them play the piano and the rest play the violin, how many students play the violin? So we are interested in how many violins. And to organize, I'm going to draw my class. And we know that our class has 30 students. Let me try that one more time. We don't want a trapezoid. 30 students. And the fraction is in terms of fifths. So let's section off 5 sections. 1, 2, 3, 4, 5. And let's drop 30 students in here. There's 5. 10. 15. 20. 25. 30. 2/5 play the piano. So there's 1/5, 2/5. These are the piano students. That word rest means subtract. So to set up and solve, you could say 30 minus the piano students. And that would be 2/5 of 30. 2/5 of 30 is how much? 12. So 30 minus 12, that's going to give you your violin students. Or you can look at this one to get the 18. Either way, if you want to use the model, you have 18 in this area. These are your violins. So either way you do it, you're going to get 18 play the violin. You could also figure 3/5 of 30 if you wanted to skip using the model. Any of those methods will get you to your answer. But follow the process all the way through. Number 16. Jack has $60. He wants to buy a video game for $35 and a new pair of shoes for $25. After buying these items, how much money will he have left? That word left is a key word for subtraction. So how much money will he have left? So to organize, we want to pull out the numbers. We know that he has $60. The video game is $35. and the shoes are $25. And we need all of those numbers to set it up. So we take the money that he has minus the money for the game minus the money for the shoes. So we have 60 minus 35 minus 25. And you can do that on your calculator all at one time. He is not going to have a lot left, but some, maybe. Or maybe I misfigured. So 0. Check your math like I did because I did it wrong the first time. He has $0 left over. 0 is a number. It absolutely can be your answer. He spent all that he had. And I forgot to highlight this question. I've been meaning to go back all this time. What are the dimensions of the rectangle? I forgot to highlight that one. That was a hard problem. Number 17. We're almost done. A fish tank is 4 feet long, 2 feet wide, and 3 feet high. If a gallon of water fills that many cubic feet, how many gallons of water does the tank hold when filled to the top? So we are looking for how many gallons of water. And you know how much I like pictures. So I'm going to draw a fish tank, or attempt to. Not that one. That looks like a fish tank I built. So let's make the long sides. And I need them to be exactly the same. So I'm going to copy and paste. Bring that in and sort of off-center it. And then let's connect. These are called vertices. Pretend those are straight and not bowed there. But there's a fish tank. It is going to be 4 feet long, 2 feet wide, and 3 feet high. It's very important that all of those are in feet. And then they tell me that 1 gallon of water fills this many cubic feet. Again, it's very important that that is in feet. So the first thing we want to do is figure out how many cubic feet are in this tank if we fill it completely up. So we're not going to just leave it half filled or 2/3. We want to put water all the way to the brim of this tank. So we're looking for a volume. And this is a formula. Volume equals length times width times height. So 4, 2, and 3 all get multiplied. 4 times 2 is 8, and 8 times 3 is 24 cubic feet for the tank when it's filled. So I'm going to set this one up using a proportion this time. You could do it other ways, but I really want to show you a proportion because this is one of the things we teach the most. So we want gallons compared to cubic feet. And they tell us that 1 gallon is this very weird looking number, but just put it down there. It's okay. And then we know that we're working with 24 cubic feet. That's the capacity of our fish tank. So that's where this 24 is coming from. And then to solve the proportion, you cross multiply. 1 times 24 is 24. And then divide it by that weird looking thing. And I'm definitely going to use my calculator on this one. So 24 divided by 0.133681. Try that again. 33681. And I get 179.53. So I'm going to call this about 180 gallon. This is a pretty big tank. But if you think about it, it fits because 4 feet long, that's a big tank. This is not something you would put a goldfish in. This is probably a saltwater tank. It's pretty big. So it would hold about 180 gallons of water. And I'm going to just move that over rather than rewrite that whole thing. So about 180 gallons. Always ask yourself, though, does it make sense? If the fish tank's 4 feet long, yes, that makes sense. That's like almost, not quite, but almost the length of a bathtub. So it's a big fish tank. Number 18. Lisa has 18 stickers. She wants to share them equally among her 4 friends. How many stickers will each friend receive, and how many stickers will she have left? So this is a compound question. How many stickers will each friend receive, and how many stickers will be left over? So we need 2 answers here. We need to know the stickers per friend and the stickers left over. So to organize, I am going to make a model. And I'm going to divide it 4 ways because she has 4 friends. And then let's start distributing stickers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I don't have enough to go through again. I have 2 stickers left, but I don't have enough to give each friend another one. So we have 16 stickers in this model. We have 2 left. That's our 18. So each friend gets 4 stickers and 2 are left over. To do this mathematically, I'm going to not use my calculator because I want to show you something. So let's do 18 divided by 4 friends. 4 into 1 cannot go, but into 18 it goes 4 times. 4 fours are 16 with a remainder of 2. So this is 4 friends. Each get 4 stickers, and there are 2 left over. So these 2 models are showing the same thing. And the answers are these. Each friend gets 4 stickers. There will be 2 stickers left over. And Rosa's worked yet again. Number 19. A bag contains 80 marbles. If 3/8 of the marbles are blue and 1/4 of the remaining marbles are green, how many marbles are neither blue nor green? How many are neither blue nor green? And I am not going to draw 80 marbles. If you're thinking, oh no, I'm not. But I am going to draw a model. So I'm going to put a bag down here. And we know that this bag represents 80 marbles. Okay, 3/8 of the marbles are blue, and 1/4 of the remaining marbles are green. So let's go ahead and calculate our blue ones. Just going to make a line here. So 3/8 of 80. That means 3/8 times 80. On your calculator, that Casio will do fractions. So 3/8 times 80 is 30. And these are the blues. So let's go ahead and color just for easy reference. Okay. So if 30 are blue, that means 80 minus 30, that would be 50 marbles left here. And these are going to be green. So 1/4 of the remaining marbles are green. So 1/4 of 50. Use your calculator. The Casio will do it for you. Okay, that makes no sense, but we'll go with it. 1/4 of 50 is 12.5. So 12.5 marbles. I don't know how you have a half of a marble. Again, I used artificial intelligence to create these. So it's the risk of using artificial intelligence. That's the green. Okay. So 12.5 are green, 30 are blue. So we want to know what this number is. How many of them are neither blue nor green? So to set this up, I'm going to take the 80 marbles minus the blues that we already found, that was 30, minus the green, so 80 minus 30 minus 12 and a half. And again, I don't know how you have half a marble, but we'll just go with it as it is. We can't just change numbers. So let's do 80 minus 30 minus 12 and a half is 37 and a half. So using both methods, I get the same answer. So 37 and a half marbles are not blue or green. And roses helped me get through that very long process. And finally, number 20. David wants to buy a new phone. He found one for $200, but there is a 20% discount. If there is also an 8% sales tax, how much will he pay in total? This is a very practical problem, something that we could have happen in everyday life. We want to know how much he will pay in total. So let's organize. We know the cost of the phone is $200, but he has a discount, that's money saved, 20% off. Well, that's 20% of $200. And then the tax is 8% of the cost of the phone. And remember, he doesn't have to pay the full $200. He's going to get that 20% off. So let's figure that discount. Let's focus right here just a minute. Let's do 20% of 200. So you change the 20% to a decimal. Of means multiply, and you multiply. So 20% of 200 is 40. So the discount is $40. So the tax will be 8% of 200 minus 40. That's $160 that he will have to pay for the phone. And now we're ready to set it up. We have the total will be the phone plus tax. The phone on sale is $160. The tax is going to be 8% of 160. So that will be 0.08 times 160. Use your calculator to do this. 160 times 0.8. That's $12.80. And remember, he has to pay for the phone. So we'll add the phone and the tax. And it looks like he would be paying $172.8. I'm going to check my math because I'm very sleepy and there are a lot of places to make mistakes. So this is set up and solve right here. But let me check my math. All right, 200 minus the discount. The discount was $40. So that makes the cost $160. And then 8% on that is $12.80 plus $160. Yes, I like that. I worked it twice and I got the same thing both times. So the total paid is $172.80. Ask yourself, is that reasonable for a phone? And it is, especially the phone at the discounted amount. All right, we have used roses to do 20 problems. I hope that you have found something useful in this video and that you feel a little bit better about solving word problems. I encourage you to use the roses method anytime you have to solve a word problem. Think through those steps. The main idea is solving a word problem. The details are read, organize, set up and solve, examine, and see if it fits. Thank you for spending time with me in this lesson. I hope that you have a very good day. Bye-bye.